In this unit, we'll explore the holes in the home's envelope, the windows and the doors. An opening in the exterior structure of a building is called a fenestration. This includes windows, doors, and skylights. These openings are constructed before the actual window or door or skylight is installed and have various components. The opening that the door or window will go into is called a rough opening. The wood at the top is the head, the pieces on the side are the jambs, and the one at the bottom is called the sill. At the bottom of a door, the sill may also be called the threshold. This rough opening is always slightly larger than the door or window that's being installed, so once the installation is complete, the rough opening area around the edge of the door or the window needs to be air sealed and insulated to avoid drafts and condensation and improve energy efficiency. Sometimes this area is filled with fiberglass insulation, a process called chinking, which does not perform as an air barrier and is not very thermally efficient either. When homeowners feel drafts near their doors and windows, this rough opening area is a likely culprit. Non-expanding foam or a foam backer rod can provide a very good air seal and insulation for this envelope hole. Or caulk may be used for the air barrier and then insulation for the thermal barrier. Window components include the frame, which is the fixed part of the window around the outside edge. The sash is the moving part of the window that opens and closes. The glass portion of the window is also called glazing or pane. Multiple pieces of glass in a window or door are called lights. You may have heard the term divided lights. Historically, muntins and stiles were needed to provide structural support for heavy glass, and mullions were used to hold smaller pieces of glass or lights together to make one large window. In today's windows, the muntins only provide minor support, and the mullions are usually just a decorative grid placed between or on the outside of full panes of glass to give the illusion of a divided light. Doors and windows that swing open also have stops that provide the edge that the door or window closes against. Windows have their own terminology and different types and have different considerations when it comes to potential energy issues. Let's review which type is which and what you need to keep in mind. Single-hung windows are windows that have a lower portion that raises or lowers to open and close. Double-hung windows look exactly like single-hung windows, but in double-hung windows, both the upper and lower sash are able to move, and many times the two sashes will tilt in for easy cleaning. These windows generally have a window lock at the top of the lower sash. These locks provide security, but they also pull the upper and lower sash tighter together to help prevent infiltration between the two sashes and around the frame as the window is pulled tightly closed when it's locked. Newer windows of this type will have weather strip around the movable portion. If they're the tilt-in type as well, the weather strip may be thinner to facilitate this movement, which makes the window more susceptible to air leakage around the sashes. A slider window is basically a single hung on its side. Instead of the sash moving up and down, it slides left and right. The locking mechanism for sliders can be pretty flimsy. It may just be a catch hook that snaps over a flange on the frame when it's closed. The weather strip for sliders is normally pretty thin as well, so that it doesn't interfere with the sliding action. Most windows can be retrofitted with better weather strip and locks if needed to improve the energy efficiency and airtightness of the window. An awning window doesn't slide. It's hinged at the top and opens outward at the bottom. The casement window is like an awning window on its side. These are hinged on one side and swing open from the other side. A hopper window is like an upside down and inside out awning window. Its hinge is along the bottom and it opens inward at the top. The jalousie window is likely the least energy efficient window. It's made up of several small panes of glass that overlap each other horizontally and crank open in unison. It's impossible to close this window tightly since the glass panes are overlapping. Interior storm window kits are about the only way to manage this leakage in the hot and cold seasons. Last but certainly not least is the fixed pane window. This window does not open. It's simply a fixed pane of glass. This is the most energy efficient design since it will not leak any air if it's correctly installed and if the rough opening around it is properly air sealed and insulated. The style and weather strip and rough opening treatment are responsible for part of the energy efficiency of windows, but there's much more to consider. Windows have an R value roughly equal to R1 per pane of glass. A single pane window would be an R1, a double pane is R2, and a triple pane window would be R3. It's not exactly a linear progression like that, as you can tell from the U values that are shown, just a rough equivalency. The area of building envelope wall that's taken up by the windows will have a much lower R value than the rest of the wall area, and so will be much less resistant to heat transfer. However, the materials used in the window frame, the coating that can be placed on the glazing, and gases that can be used to fill the space between the panes all impact the energy efficiency of the windows. Window frames made of fiberglass or wood help increase the thermal resistance of windows. Metal window frames can conduct heat very quickly, as metal is a great conductor. Thermal breaks of some type of rubber or insulation or other non-conductive material between the inside and outside window frames are commonly used to prevent this conductive energy loss. Warm edge spacers are placed around the edges of the glazing. These spacers allow the various materials that are used in the windows to expand and contract at their normally differing rates without breaking the window seal. The spacers may also include a desiccant to provide a moisture barrier and keep the windows from fogging. And the seal that the spacers provide help keep any gas fill that might be in the window from leaking out. Some windows have an argon or krypton gas that increases the insulative value of the window. Another method used to increase the energy efficiency of the windows is to place a low E coating on the glass. The E in low E stands for emissivity. Lowering the emissivity of the glass increases its thermal resistance and the ability to reflect radiant waves. This means that the low E glass will end up absorbing and therefore transmitting less heat than clear glass. If you're trying to keep the heat out of the house, you want the low E coating on the pane that's on the outside of the window assembly. But if you're trying to keep the heat in the house, you'd put the low E coating on the pane that is on the inside of the window assembly. If you want to use the sun's rays for passive solar heating, you'll likely be using clear glass, so the sun's heat can be harnessed inside the home. Window glass will transmit between 20% and 84% of the sun's heat depending on the type of glass, the number of panes, and other window assembly treatments. If the house is in a heating and cooling climate, the north and east facing windows may have a low E coating on the interior and a low E coating on the exterior of the west facing windows, with clear glass facing south. The energy performance rating of a window is tested and certified by the National Fenestration Rating Council, or NFRC. New windows come with an NFRC sticker that provides construction details, such as the type of window, whether there's any gas fill, and whether there's a low E coating. The NFRC sticker also includes the energy performance rating for that particular window. It's important to leave this sticker on the window until all inspections and verification visits by energy professionals and code officials have been completed. The amount and orientation of windows is very important to the effectiveness of the home envelope. We all know that the sun rises in the east and sets in the west. The sun's angle and height above the horizon changes depending on the location's latitude and the time of year. In the summer, the sun is high in the sky, almost directly overhead at noon. In the winter, the sun is lower in the sky and goes along a southern trajectory as it moves from east to west. The path of the sun at its highest and its lowest, bounded on the sides by its location in the east at about 9 a.m. and in the west at about 3 p.m., creates a curved rectangle known as the solar window. This is the window through which the sun's rays will reach the house if they're not blocked. Windows facing south will have a solar gain in the winter when the sun is low in the sky and should be shaded by overhangs in the summer when the sun is high in the sky. Windows on the east and west will have solar gain in the morning and the evening, and the sun will be low in the sky at these times, no matter what the season is. In the summer, some type of exterior shading, perhaps from trees, lattice work, or shutters, is critical if the goal is to keep the heat out. The windows on the north side of the house will not have any direct sunlight strike them. These windows should be minimized so the envelope can be fully insulated on the north side. Window overhangs are a major building science consideration. This is because the windows can transmit so much of the sun's heat from the rays that strike the glass to the interior of the house. This heat load must be considered when thinking about the sizing of heating and cooling equipment as well as occupant comfort. In northern, cold climate states, the sun can provide free heat through the south-facing windows when it's low in the sky, and overhangs can keep the windows shaded in the summer when the sun's high in the sky. In southern, hot climates, overhangs may not be enough. Trees or other external shading may be required on the south side of the structure to shade the windows in the summer. The depth of the overhang from the exterior side of the envelope wall to the edge of the overhang, measurement A in this picture, and the distance from the bottom of the overhang to the bottom of the window, measurement B, are the measurements that need to be considered. The appropriate overhang depth to shade the window from the summer sun varies by latitude. However, in the center of the United States, if the overhang is about 1/3 of the full height of the window plus the length to the overhang, the shading works very well. We've discussed windows quite a bit. What about doors? Doors are made of different materials that impacts the energy efficiency of the door. There are wood doors, and since we're only concerning ourselves with the building envelope, these will likely be solid wood doors. Some exterior doors are steel, and the more energy efficient steel doors will have a urethane or a polystyrene foam core to provide insulation and a thermal break. The doors with the highest R value are fiberglass doors. Material is one factor to consider, which gives us the thermal characteristics of the door. The other is the weather strip and the threshold, plus the fit of the door against the weather strip and threshold, which ties to our envelope air barrier. Doors are fenestrations too, so they will also have an NFRC, National Fenestration Rating Council sticker, that provides information about the door's material as well as the energy ratings for both the opaque or the door area and for any windows that might be in the door. Many doors are actually more like windows, and all the window items we have covered influence the glass doors too. Full glass doors are so much like windows that sometimes it's hard to tell which unit is the door. French doors are a special type of full glass door in that both sides will open. This means that it's really two doors, and both sides need to have weather strip around the outside. But the center where the two doors meet also needs a good air seal. The lights typically found around doors, which include side lights on one or both sides, a transom above, and of course any window in the door, are normally manufactured with the door and installed as one full unit. These windows usually have a different energy efficiency rating than the rest of the windows in the house. When we punch holes in the building envelope, we need to be cognizant about how the thermal and air barrier in the house will be maintained. As you've learned, there's quite a bit of building science behind the materials, the installation, and the orientation of windows and doors.